Hello everyone. Hope we're all good in health, doing fine. So welcome to the session. The objective of this session is that to introduce you the second PUC physics lab for you. So today we are going with the experiment number 1, that is resistance per unit length of a wire. The aim of the experiment is to find out the resistance of the given wire by plotting the graph of current versus potential difference. So we know that the resistance is the opposition offered to the flow of charges in a conductor, in a material. We know that each material has its own resistance. So we take a wire and we are going to find out the resistance of that wire today. Apparatus, the wire, what we are going to find out is the resistance, battery, voltmeter, ammeter, plug key and rheostat. You will get to know once we go with the experiment. The principle I am using here is Ohm's law, a very important law with respect to the electronics. It says that at constant temperature, the current flowing through the conductor is directly proportional to the potential difference applied across the ends of the conductor. That means the current is directly proportional to potential difference. So I is proportional to V. So if we equate, we introduce a constant. So V is equal to I into R. So R is a resistance. So that's what I am going to find out here. So R, I plot the graph where M indicates the slope of the graph. So I find out the graph, hence I find out the resistance. So let's go with the circuit connections. So here we have the circuit diagram for the experiment. You see, I will go with the positive of the battery. So we can identify that it's the battery end. The positive end will be lengthier and the negative end will be a little bit smaller compared to this one. So we can easily identify that it's a battery. So the connections are always made from the positive of the battery. So this straight lines indicates the connecting wires. The straight line indicates the connecting wires. So from positive of the battery, the connection goes to ammeter. From the ammeter, you can see to the resistance. So here, this is the resistance. The material, I am going to find out its resistance. And the voltmeter is connected in parallel to the resistance. So the voltmeter is always connected in parallel in a circuit. You will get to know why it's so. Then from this connection, the connection goes to the rheostat. So this is a very special one, a variable resistor. A variable resistor, and it's a 3-terminal device. So one here and another one will be here. So the upper terminal, here we are not making use of the third terminal, I can say. From the rheostat, the connection is goes to key, from key, negative of the battery. So this is the circuit. We'll go with the connections. So once we go with the connections, we will enter the tabular column and then we will plot the graph. So this is the expected graph. From Ohm's law, we say that the current is directly proportional to the potential difference. So whatever the changes happens in the potential difference will be there in case of current. So you will obviously get a straight line. The slope of this graph will be the resistance. So let's we will go with the circuit connections and find out the results. Okay, let's have a look at the apparatus that we are going to use it in the experiment. The first battery, the source, and here the milliammeter, the readings from 0 to 500 range. Then voltmeter, the range is 0 to 5 volts. It's the plug key to switch on and switch off the circuit easily. The rheostat, a 3-terminal device. Upper terminal, here one. So the rheostat is a variable resistor. By moving this portion, we can able to vary the resistance. And very importantly, the resistance wire, the material is of nitro. We are going to find out the resistance of this material. And here we are with the connecting wires. So let's start with the circuit. So I would like to start from positive of the battery. One of the easiest way of remembering or connecting the circuit is just place the apparatus as it there in the circuit what you have written. So better ways. First, positive of the battery, to the positive of the ammeter, then negative of the ammeter to the positive of the voltmeter, the negative of the voltmeter to the upper terminal of the battery, upper terminal of the rheostat. From another end, I'm connecting it to the key. From key, negative of the battery, from key the connection goes to the negative of the battery. Okay, so this completes the one more thing remaining, the experimental wire. So I am connecting it in parallel between the voltmeter. So its resistance we are going to calculate, and it's actually of length 1 meter. So this completes your circuit connections. You can cross check once, going from the either from the positive of the battery or from the negative of the battery. Go in a cyclic procedure. So positive of the battery to the positive of the ammeter, from ammeter to the negative of the negative ammeter to the voltmeter, from negative of the voltmeter to the rheostat upper terminal. This is important. Then another end of the rheostat to the key to the negative of the battery. So this completes. Let's make a closed circuit. So once I close this key, the circuit is ready. So let's start with this. I'm switching on the battery. So you can see when I move this rheostat, the readings are changing. Now you can see the key is closed. I am not varying the resistance, so the readings 0 in the milliammeter. And also here the voltmeter shows 0. Now I vary the resistance from 0 to maximum. I vary the resistance, so the current changes. You can observe in the milliammeter. Okay. Yeah. So here we are going to take down the values in an order of the voltmeter range from 0.1, 0.2, 0.3, 0.45 like that, and the corresponding current values. So first, it's better we should use this in a proper way, the key, because if you continuously doing the experiment, the change in temperature might happen in the experimental wire that will lead to the unnecessary results. So it's better when you take a reading, take out the key, write down the reading, then again you can go back. So first I am fixing the value. .1. So the corresponding for 0.1 volt, the corresponding current will be noted down. So the current shows after from 0 it's at the two lines. It's after two lines. That means you can see here the milliammeter range is from 0 to 100. There is 10 lines between 0 to 100. Each line value is 10 milliamperes. That we can easily guess. So if the needle or the pointer is on the second reading, that means it reads 20 milliamperes. So like the way we move on. Now I am going for the value 0.2 volt. So the corresponding current will be on the fourth, the pointer will be on the fourth line. So it indicates that 40 milliamperes. Let's move on faster. 0.3. Yes, so 0.3, there it will be so it will be 6 on the 6th, the pointer will be on the 6th line, so it indicates 60 milliamperes. So now 0.4 volt, 0.4 volt. So you can expect the pointer will be on the 8th one, so 80 milliamperes. So the process goes on. So one thing you can identify, I am switching off the circuit. 4, 5, 6 values, those are all enough. What you can follow from this here is, initially when I placed the voltage to the 0.1, the reading was 20 milliamperes. When I change it to 0.2, so the reading of current is 40 milliamperes. So it's going on. So the change in current, let us say 0.3, 60 milliamperes. So the whatever the change happens in the current, the same change is result in the voltage. So the current flowing through the conductor is directly proportional to the potential difference applied across the ends of the conductor. So I am going to take the 5 readings here. Using that 5 readings, I will be plotting the graph. So we get a straight line, we calculate the slope, then we find out the resistance. So let's move on. Here are the values that we got from the experiment. Current and corresponding voltage. So 0.1, 20 milliamperes, 0.2, 40, 0.3, 60 milliamperes, 0.4, 5, 6. It goes on. Now I am going to plot this using these values. I am going to plot the graphs to calculate the slope and then the resistance. So here we follow. Here is the scale. I have taken voltage in the x-axis and current in the y-axis. The scale, first I will write the scale. It's very important. X-axis 1 unit is equal to 0.1 volt. And y-axis 1 unit is equal to 20 milliamperes. Okay. So now first value, the voltage 0.1, the corresponding current is 20, so it will be 0.1. The value will be marked here. Then for 0.2 voltage, the current is 40. So here it will be 0.3, 60 amperes, 60 milliamperes. So it goes on 0.4, 80, 0.5, 100, 0.6, 120. So I join all the points. So you can see the line joining all the points will be passing through the origin. So you can able to see the points. Okay, yeah, better. So one thing for sure, here as the potential difference changes, the current is changing. So it obeys Ohm's law. So straight line indicates that the potential difference applied across the ends of the conductor is equal to the current. So let's find out the slope. I am taking from this one. Call it as A, B, and this point is C. You can easily guess the value of AB is 100 minus 60, that is 40, and AB corresponds to current. AB is equal to 40 milliamperes. You can see this point A corresponds to 100, the point B corresponds to 60. So the length AB will be 100 minus 60, so that will be 40 milliamperes. You can see BC 0.5 minus 0.3. So BC is equal to 0.2 volts. 0.2 volts. So from the diagram, slope is equal to AB by BC. AB 40 milli refers 10 to the power minus 3 whole divided by BC, that is 0.2. On solving this, what we get is, I can write it as 40 into 10 to the power minus 3 divided by 2 into 10 to the power minus 1. So this will be 20. This minus 1 shifts upwards, becomes positive. So 10 to the power minus 3 plus 1 is minus 2. This is the slope. So finally we got slope, and slope is represented by M. So we got M. So M, finally the resistance R is equal to 1 over slope, that is 1 over M, at 1 divided by 20 into 10 to the power minus 2. So 10 to the power minus 2, I shift it upwards, 10 to the power plus 2, that is 100. 100 by 20 is 5. The finally the SI unit of resistance is ohm. So we get the answer 5 ohm. So we started with the experiment to calculate the resistance of the given experimental wire. And finally we get the by the method using the principle of Ohm's law, we got the value of resistance, and it's 5 ohm. So we are using the material nichrome. Of course, the resistance of the material nichrome, alloy nichrome, is also 5 ohms. So we are getting the exact results here. So this verifies Ohm's law, and it gives us the value, resistance. And final part is that resistance per unit length. Resistance per unit length. I'll make use of another portion here. Resistance per unit length, that is R by L. So resistance is 5, and the length you can take it in centimeter or in meter. I am making use of meter here. So the length of the wire, experimental wire, as I informed, 1 meter. So the final answer, resistance per unit length is 5 ohm per meter. 5 ohm per meter. If you make use of centimeter, so you can get 5 into 10 to the power minus 2 ohm per centimeter. It's okay. So this is the final result required of the experiment. Resistance per unit length of a given wire, or resistance per unit length of a experimental wire. Okay, thank you everyone.